two-step rules. I ain't afraid of you. I should say I'm not afraid of you. I guess that's proper English, but I ain't afraid of you. Input and output, same thing again here. Two-step rules, come on. This is cupcakes. Um, the only thing that we have to worry about here is make sure we solve it one step at a time. So the input here is 2. I'm going to do 5 times 2 because that's what x is, plus 3. That'll be 10 plus 3. And we'll get 13. And you're probably going to say, this will drive me nuts because I have to show all this work. You know what? It's going to take you like 3 extra seconds, all right? So I wouldn't worry too much about that. All right, 5 times 5. Yes, I want you to show the work. The thing is, if you don't show the work and you try to do too much at once, you try to go I can't even say it. See, look at me. You try to go through it too quickly, you're going to get things wrong. We don't want that. So we get 5 times 5 is 25, plus 3, that would be 28. So all I'm writing here is the original expression after we substitute, and then we can put the output over here. So I'm actually going to go ahead and fill in all of the substituting, and then I'll do the solving afterwards. You can do it like this too if you'd like. So we get 5, and then the input is 7, so we substitute a 7. 5 times 7 plus 3, and then here would be 5 times 11. So we're substituting that in. We got a little machinery here working for us. This is going to create an output, 5 times 7 plus 3. And of course here we do multiplication first again. Order of operations says so. 35 plus 3 is 38. And then finally 5 times 11 plus 3. That's 55 plus 3, which is 58. I forgot to fill my other one in up here, so I'll do that too. We had 35 plus 3, and that, of course, is 38. So we'll write that in here. Yeah, that's all it is to do two-step rules. Now we're going to take it one step further. What about if we were working backwards and we were only given the output? Well, this is a perfect case for inverse operation. The way to think about this is think about it like it's an equation. So imagine if we have x minus 8. Minus 6. We don't know what x is, but we know it equals 4 when we do x minus 6, right? Because that's the first output they give us. So it's an equation. Perfect example of using an equation. Do the inverse to both sides. We get x minus 6. We add 6 there, so we add 6 here. And these 6's would cancel out, and we'd be left with x equals 4 plus 6, which is 10. So your input here would be 10. And then the great thing about the way this is set up is you can actually check your work now. So substitute for x is 10, the input's 10. And then we do minus 6, and sure enough that gives us an output of 4. We could do that throughout here. So next one, x minus 6 is still the function rule, equals 9 now. If we add 6, that's the inverse operation. Now x is isolated, it's all by itself, that's what we want because we're trying to solve for x. And we add 6 to this side, and we get x to equal 15. And if we put that into our input here, we get 15. We have 15 minus 6. That leaves us with only 9. And finally, one more time, x minus 6, that's our function rule, equals 2. That's our output, or our dependent variable. We're going to add 6 since that's the inverse. Those 6's cancel. We're going to add 6 again, and we're going to be left with x equaling 8. Alright, 8 is great. The input here is 8, and of course we'd substitute 8 in there for x, and 8 minus 6, we should have got 2, and we did. Hey, alright. Let's take it one step further. It's going to get more and more difficult here as we go. Oh no. Alright, this time you notice that this is 2 rules. So we're going back to what we did at the beginning when we had two-step expressions, which eventually now we're going to do two-step equations. And on the last thing we just did, we only had the output. Now we're combining those two things. So again, we're going to pretend that this is equation. So 2x minus 6, we know it equals 4. And we know in the second output, 2x minus 6 equals 8. Alright, so we have all three equations written down. All we have to do is solve them. Now when you solve two-step equations, we actually haven't seen this yet, but we're actually trying to solve, we want at the end of the problem it to say x equals something. And so in order to do that, we need to add 6 to both sides here because we got to get rid of all the numbers. So we're going to add 6, so we get 2x equals 4 plus 6 is 10. And if you do this out, we divide by 2 on both sides. Those 2's cancel. X equals 10 divided by 2, which is 5. Now watch what happens when we put it in. If we did 2 times 5 minus 6, we'd have to check our work here. We have 2 times 5 minus 6. 2 times 5 is 10. Minus 6 leaves us with 4. And that's what we said we got for the output there. Kind of difficult process. Let's try it again. Let's do another example. So if I add, again, the first step here is to add 6, because we want at the bottom of this problem it to say x equals something. We're trying to figure out what x is. So if we add 6, we're getting one step closer to getting x by itself. So we have 2x equals 14, and then multiplication, the inverse is division. Those cancel. Whatever you do to one side, do to the other. X equals 7 in this instance. So your input 7, and that would mean that 2 times 7 minus 6. And to check this, we'd multiply first, and sure enough, we get 8. Last problem, you pause it right now, see how you do on your own, figuring out what the input would be in this situation. Okay, the first step we would do is add 6 to both sides, because we want to get x by itself at the end of this problem. The 6's cancel, and now what we have is 2x equaling 8, right? 2 plus 6 is 8. We divide by 2 on both sides of the equation. These 2's will cancel out. And in the end, we're left with x equals 4. Alright, so what we have here is 2 times 4 minus 6. And to do this out, we would do 2 times 4 minus 6. And sure enough, we're left with 2. Alright, function tables graphing. An old car can only reach a top speed of 50 miles per hour. The function rule that represents this situation is 50 times x, where x is the number of hours. Make a table to find how many hours a car travels after 150, 200, and 250 miles. Then graph the results. So you can see our function rule is right here. And what have they given us in this problem? They have not given us the hours. They're saying x is the number of hours, and they're saying we'll give you the number of miles. You can see here, right here, they gave us that. So down here in the chart, we're going to write the number of miles which they're giving us. So they're giving us the output here. Alright, and they're saying 50 times something equals 150. So to do this out, we would just write the expression first, which is 50x, the function rule. And we're saying now it's an equation. It equals 150 miles. And to do this out, we would do the inverse to both sides. We're going to divide each side by 50. Those cancel. We divide this by 50. And if you recognize this, when you divide numbers that both have zeros on the end, really you can cross off those zeros. And you'd be left with 15 divided by 5. So x equals 3. And again, we can check this. If we did 50 times 3, it would equal 150. So that makes sense. Alright, I'm going to solve this one for you. So we had 50x equals 200 now. The 50's cancel. X is going to equal, when we do 200 divided by 50, that equals 4. Because again, these zeros, they cancel. So it's like saying 20 divided by 4. So we'd put 4 in for the hours. And then 50 times 4 will equal 200. And then one more time here, 50 times x equals 250. The 50's cancel when we divide. You divide by 50 on the other side. And you end up with x equaling 5 hours. So we've created the table. Now we need to graph the results. And you can see here there's an x for hours. That is your independent variable. That's the number that regardless we're going to work with that number. Now the miles depends on the hours. So you can see up here when we graph, we generally put y up here. This is like your vertical axis. And then x is your horizontal axis. Miles, because that's how much you go in 1 hour. What they've asked us to do is 3 hours. So We go up here to 3 and 150 is the y coordinate, and we'd put a dot right there. And I'm just going to write in parentheses the coordinate. And at 4 and 200, there would be another coordinate. And then finally, we're going to go to 5 hours and 250 miles for the last one. So here's 5 hours, and we go all the way. Oh, I forgot to write in a 250 up here. But you can imagine, since it's going up by 2 each time, see from 150 to 200 it went up by 2, that it would go up to right here on this line right here. So if we go straight across, that would be an appropriate point, and we'd get 5 hours and 250 miles.